Here's my nearly perfect little Benchy on my Robo 3D. Actually, first one I ever bothered printing. Can't get in there to see the front very well. We'll come up here. And so this is no support. It's a little heavy-handed in terms of the settings. I ended up using settings that I typically am using for some of my heavy-duty parts. So this has like 3 layers and probably 25% infill or so. But my plan is that I will take these exact same settings and apply them to the FT-6 and see just how well it does. So we will check back later. Alright, so looking at it after popping it off the printer, as you can see there's some stranding, and so the long horizontal run with no support didn't do too bad. A little bit of hanging threads there. The arches and stuff did pretty well. The circles. I'm used to printing stuff like that, so I didn't have any expectations it would be a problem. Stack looks good. The little rib along the edge here, you can see that level of detail, as well as the 2 holes here. There's a little bit where it had the really strong overhang here, and I'm not sure why the little brown spots, what was happening with the filament there. And of course I did this on a raft, but you can see the actual CTSO. Anyway, in all, pretty good. I guess it says Benchy probably on the back. Decent print. We'll see how that looks printed using the same filament and settings on our new printer, if I ever get my parts from Amazon. Well, since Amazon and UPS kind of let me down, the long cables that I ordered from Amazon with my Prime 2-day delivery, actually, for some reason, they decided to ship it ground from Colorado, which turned into an over the weekend. So instead of bringing it Friday, it was supposed to arrive Monday. Unfortunately, UPS had problems and it got hung up in San Antonio. And it's supposed to be delivered today by 8 o'clock, and as you can probably see from my clock, it's now almost 7:40 and still no cables. So since I'm running out of time, I decided to come up and try a few other things. So I figured I'd go ahead and test out my bed heater and my tip heater just to see if they do anything. And so the one thing, I was a little concerned when I was seeing how noisy my readouts were for the 2 temperature sensors for the beds, or for the bed and the tip. But as soon as I turned the power on the board, then this cleaned up. So remember, the Arduino is actually running all the time. So as long as it's plugged into USB, you're actually talking to the processor on the board. And so in this case, we actually started taking valid data once the power was actually turned on, so it's powering up the circuitry that the sensors are connected to. And so we've got the bed heater and the tip heater both connected now, and of course the bed heater is the one that is going to take 110, and so it's currently set to 55. Let's go ahead and flip it on and see if things start moving. So there it goes, and of course what you see is that the target just jumped up to 55. And lo and behold, we're seeing that light blue curve that is the bed sensor starting to rise. And now that we've got a little bit of time on it, why don't we go ahead and let's push it up to 200. It won't hurt to at least hit it initially. So let's turn the extruder on as well. And so now we're watching that red line, which is probably going to bypass the bed temperature very rapidly. And there it goes. And so feeling the bed, it's definitely getting warm. Although the instant I get off of that rubber pad on this aluminum top, it's still nice and cool. So forget about printing anything where you care about the bed temperature out beyond that edge. And we're seeing a nice, very exponential. Now, as it's getting warmer, I'm feeling the heat transition out to the edge. It's just the edge is never going to be as hot as the center. And of course the tip overshot, and now it's going to cycle. You can see where the bed overshot as well, and it's going to oscillate a little. So these two will probably stabilize at about the same time. So our bed's 54.4, extruder coming back up to 200. And if only I had a extruder cable that I could drive that motor with, we could actually try doing something. Now, since I've got the tip warm and it's getting very close to stabilized, they have a nicely damped control curve on that. It overshot once, it comes back, and now it's not overshooting at all. So it's strongly damped is the way we would refer to that. The bed's oscillating a lot more, probably because it's got a large volume, but it's only got that one sensor. That's an interesting problem too, that you would there's some potential, depending on how the heater itself works, that this thing could end up being different temperatures at different ends of the bed, but hopefully that won't be the case. Now, it's interesting looking at the curves on the bottom, watching how it was on solidly, and now you're basically seeing the pulse control that's actually maintaining the temperature and the actual power output. Okay, so we're pretty well stabilized at 200. So let's hit my fan and see just what it does to the tip, because I think that'll be an interesting thing to evaluate. And so I'm going to step over here and be sure the fan is running. Looks like it's running fine. And you see the tip go down a few degrees, and so we can expect it to stabilize here very shortly. The good news is there's not enough wind blowing on it to that it's really cooling the tip. The tip's able to compensate. So, all right. Well, I just got a signal that I actually have a package from Amazon. So give me a few minutes to hook some cables up, and we will give it a shot to see if we can actually print something with this thing. My Amazon Prime that wasn't so prime, but here's what I had to order. So these are supposed to be 2-meter long cables. It actually came in a 3 set. And so we're going to open this up, double check the wiring against the ones we have to make sure the color code all lines up, and then install them. Given my time crunch this evening, I don't think I'm going to finish and actually route these pretty. I'm just going to get something running so that we can try a test print. Now, I already mentioned in my original wiring video on this, but I want you to take note of just how much nicer it is
to have a simple ribbon cable. There's absolutely no reason. It doesn't cost any more. If you looked at the different ones for sale, the ones that were ribbon cables didn't cost any more than the ones that weren't. And so that makes the wiring so much cleaner. And I'll be very happy because these will slip right into my tubes very easily. Now, the one thing, and they warned about this on the website, so if we compare, very carefully in here, if we compare the color codes, we can see that the small connector looks the same. So we have red, blue, you can see, let's try to get this angle, red, blue, green, and black on both of these connectors, facing that direction. And I'm going to go ahead and power off the printer here. I think we're cooled down enough. So let's kill the printer power. Now, the issue is the other end. Oops, that is not the other end. This 2 meter long cable is a little tough to keep hold of. Okay, now here's the other end facing the same direction, and what we have is red, black, blue, and green compared to red, green, blue, and black. So what that means is that the polarity of one pole on this is probably swapped. This is a relatively easy thing to fix. Basically, you just need a small point, and the little white tabs, you just lift those up carefully, and that pin will slide right out. You just swap the two, and we'll plug it right back in. So I'm not going to try to do that on camera, but give me a minute, and I'll get those swapped around. Alright, so they're using a very fine tip screwdriver. We just lift up the two little white tabs and we've pulled these two pins, and we'll just pop them in, making sure to push the white tabs back down, and also being sure, you see how there's that little clip that hangs off the end of the pin. So got to make sure we plug that in correctly. Alright, and having gone through that process a second time, we now have two black, blue, green, and red on the stepper motor side. So I'm going to get these plugged in, and we'll see if our Bowden steppers move and which way they seem to move, if I can tell. Alright, so there are my two cables attached, and so while I'm still going to have to dress this cable with P-clips down the back later, it was so incredibly easy to slip these ribbon cables into this tube. They basically acted like just a knife edge. Once you got that ribbon into the slot, it just opened the slot for you the entire way, and you just pushed them in. So compared to running any of the other cables where I typically needed a nice smooth curved tool to keep from cutting anything, you know, this was very easy to put in, so I went ahead and ran them. And so now we have our two ends, which I quickly labeled with an R and an L for right and left from the front. That will at least help me figure out as I need to swap these back or forth. And so now those are going to go into the last two sockets we have, and we'll see if they turn the correct direction or not. Otherwise, we'll swap them. Alright, so for starters, I'm trying right on right and left on left, and we'll hope that that's correct, because again, just like working at the other end, with this thing here, this is an incredibly tight working space. So getting that corner connector in there, I actually used the end of my tweezers as, you know, again, something not likely to cut things, to push that all the way in. So hopefully I won't have to remove that. I might actually change the firmware if I had to, although that could lead to problems down the road. So let's go fire this up and see what happens. Okay, so we are now back on our application. You can see we turned the power on and the temperature sensors are reading smoothly. Let's see if I can set the camera up here somewhere that will potentially be stable enough. So I've attempted to mount the camera in a position that if it will remain stable, you should be able to see everything that I try to do. Now the first test is simply to try running the extruder, and I'm going to assume that the down is driving filament into the feed. But the first thing I got to figure out is which of these two move, and I'm not 100% sure how I'm going to tell that, but let's give it a try. Something. Alright, so something just ran and made a bunch of noise in the process. So that's Extruder 2. So why was Extruder 1 not running? Okay, now they're working. So the challenge, obviously, with this thing on the back of this printer is I'm a big, tall guy, and this is still a challenge for me to reach. And structurally, this whole printer is also not really that solid. So, okay. So I'm sticking that filament right up to the teeth. Let's see if it catches. Maybe I have to actually press this, which is almost impossible to do. Okay, now the filament is caught. Let's see if it'll drive through or if it backs it out. Filament is still captured, but I can't tell that it is moving at all. Hey, there we go. Now I can see the filament going down the tube. Okay, that was a pain in the butt. But now that I can see it going down, we should be able to come over here. And if you watch, hopefully, well, that looks like that's backing up, doesn't it? So guess what? I think we're driving backwards. Yeah, we're driving backwards. Okay, so guess what? This is Extruder 2, the other's Extruder 1. So now we get to pull that and swap this around. Come in and we swap these two motor drives. So, right is left, left is right. Which to some extent makes some level of sense that the left would be number one up there on the mount and the right would be number two. Alright, so with that, yeah, this thing is going to be very hokey in terms of something that the average user can deal with. I can barely push these in. And if I were to get any older and started having to worry about arthritis or something, there's no way I'm going to push that. So maybe that's going to be a new task, is to come up with a tool for engaging this thing enough. Dang, those screws are hard on your thumb too. It's like you want it to be tight, but and I'm wondering if those little screw holes I'm seeing in here aren't related to giving you a way to basically guide this whole thing. Okay, now that we believe is Extruder 1. And we believe this is the down direction. And we got to turn the power on first. Alright, turn the power on. Let's go ahead and start heating the bed and the hot end again. Go ahead and home, make sure everything's happy. Well, fatal error. The printer side stopped. The printer problem fixed. Oh, thermal runaway. Let's just disconnect. Yeah, go ahead and disable them. Yes, disable. Apparently it's having trouble communicating. Alright, let's start from scratch. Let's unplug the USB so that the COM port goes away. Let's turn the power off. And probably come back and even close Repetier at this point. Okay, just telling it not to disable, then it's happy. Alright, plug it back in. Turn it back on. And now, reconnect. Tell it to home. Does all of its little gyrations. Go ahead and turn the bed and the extruder back on. And now let's tell the extruder to pull, I assume it's 100 millimeters. Extruder 1. And that doesn't want to move. Here we go again. We'll go to Extruder 2, will it run? So motor 2 runs. It may be that it's heating and it doesn't like. Alright. I think that's the issue. I think it's that Repetier, without the extruder being hot, it doesn't want to let you run the extruder drives. Alright, I don't know how far we have to go to get there, so I'm going to start cutting this back a little bit because I don't want to run a massive amount. But I should be able to see when it starts coming into the feed tube. I hope. Not 100% sure now whether this tube is the front tube or the back tube. Running 50 at a time, as you should be able to see from the screen video. And I'm going to tilt this down. And of course this is right in the way of the tubes. And actually I think you'll be able to see the tube. So, I believe when we start seeing orange in those tubes, we will be where we want to be. There it comes. Look at that. Alright. That's a millimeter. Or that's a centimeter. So 10. should see something come out on the bed, I hope. I think I see our first little bit of extrusion. Let's send our Z-axis up. So that we can actually watch it fall out of the tip. Oh, there you go. That did not sound good in terms of the Bowden. Yeah. That should be able to feed that rate. Let's try this. This is probably the slower rate. So that was fast feed. There we go. So now that's feeding a centimeter worth of filament at a rate that the extruder can handle. So the one button is for feeding fast to try to get this thing down the tube. The other is for actually extruding off the extruder. I've got this nice little ribbon that's hanging down the side of the bed. Now that we are that far along, now it just remains to see what happens if we print. Now the problem is our bed offset. And so I've been playing around and just kind of leaving, starting with the default Cura settings. Oh, I restarted this. So let's open our Benchy. Sitting right there in the middle of the bed. Alright, now I have no idea where this is going to hit, and I haven't really cleaned the bed or done anything in the way of prep. I suspect this will stick to this aluminum quite nicely, but I am going to operate under the assumption that we're going to print somewhere in here. Don't try this at home, children. The bed is nice and warm. But if you're careful, that should be okay. Alright, so slice it. We're doing no adhesion, 0.2 millimeters. So like I say, I'm just trying the defaults right now. I don't expect this to even stick the first time around because we're going to have to tweak the height. But what I'm going to attempt to do is while it is doing the perimeter, I should be able to tell it manually to go down a little bit, I hope. So, slice with Cura. While it's doing that, I'm going to get in here and get rid of our leakage coming off the head. Again, another reason why I love these tweezers. Alright, there's our completed result. And let's just tell it to print. And we will see what happens. Now, that is interesting. I don't know why it ran the bed way down like that. I don't know if this thing's smart enough to automatically be doing the multi-point leveling. Happening. Oh, we missed the
Missed the tape by a ways, and we aren't sticking it all, so let us figure out how to stop. Let's go back and let's just home everything. Print height didn't actually look too horrible. Whoops. Now, the one concern that I have here about this inductive sensor, yeah, because on the tape that actually stuck. Very good. So, I think what I will do, just to help ensure that this is going to have a chance of succeeding, I am going to change one setting from the default. I'm going to tell it to go ahead and use a raft. And I think with a raft, this should be relatively successful. Let me get some Z height here. You can already tell. Raise it 10. It'll take me a little bit to get used to the negative direction of things here with this bed compared to my Robo that lifts. Alright, so let's go back to Slicer. Let's change the adhesive type to a raft. Leave everything else the same. Tell it to slice. You notice it did not do any sort of automatic leveling of the bed, so it's relying solely on the fact that the one thing I don't believe I've caught on any of the videos was I basically went around using the magnetic sensor and adjusted every screw on the bed to get the sensor basically to trigger at roughly the same level. Now, this bed is pretty warped, and what I was seeing was that by the time I made it around to the back and got to the original screw where the reference was, that screw was very loose, because as I pulled down all the other points to get them to the same level, the back here of the bed was actually lower. So still somewhat problematic, but let's give this a shot. And I may leave the video running for the 50 minutes it's going to take to test this, but I'm not necessarily going to stay here and talk to you for this time. Whoa, just barely caught the tape. But, as rafts go, that looks pretty good. I am going to turn the ceiling fan off because I don't think this needs any additional cooling. And I will say, compared to the settings that I used to capture this Benchy on my Robo, the current default settings here of the slicer are considerably faster, because this is closer to what they actually say this should print in 52 minutes with the raft. That left a nice little ugly spot. Whereas on my test print on the Robo, it was closer probably to 2 hours for the settings I had. But again, much more infill, much thicker walls, etc. Well, for not doing anything to calibrate and just slapping a piece of tape down, I'm pleased so far. Now, my comment that I started to make as I was putting the tape down, I would love to be able to fix these screw holes and come back and put a piece of glass on this and print on glass, because that's what I'm used to. It would also give you the option of actually pulling the whole part off the print bed without fighting. I mean, this thing is just not rigid. If I get a big part on here, I'm going to be putting a lot of force trying to pop that off of the print bed. Now, I don't like doing that on glass either, but
frankly, if I break a cheap piece of glass, I'm okay with that. I don't want to break the whole darn printer. But my concern is that the inductive sensor doesn't know anything about that glass. It is going to still sense the aluminum, and you can see how close our sensor is to the surface. I can't fit a even a 1/16 of an inch worth of glass in there. And I can see now, I haven't been watching the video. Let's push this down a little. There, now you can actually see what we're printing. Sitting here watching the screen and watching what's happening, but not looking at my camera. And I don't know if I were to zoom. Unfortunately, what I'd like is a pan. It doesn't let me do that. So let me see if I can very carefully move this while it's zoomed in. There you go. Alright, so we're still working on the raft, it looks like. Which is a much denser raft with the Cura slicer here than I'm used to. Basically, I think I've used everything kind of default on Matter Hacker with the Robo 3D. Well, as entertaining as this is to watch, the reality is I've watched 3D printers print before, and given that it appears to be running, now the one thing which you can't see that I'm sitting here watching is, on this long span, that return belt on the drive is basically it's sitting there vibrating, like a guitar string or whatever. More so on the front side than the back, so I don't know if that means I just need to tension a little more. But vibration like that is definitely going to impact print quality. So I don't want to move the camera to show you at the moment, but now, the problem is I really want to need to get power to this thing because I don't think it's going to last an hour without just on battery with this camera. But since I plan fast forward, there we go. Now we're printing the bottom of the Benchy. It looks pretty clean. You can see when it peels off of the raft what it looks like, but at least as far as what the slicer did, I like it. It has nothing to do with the printer, solely has to do with the default settings on the Repetier software, the Cura engine. One thing I will remind you about the results of this benchmark, and I might come through later and turn the fan off. Now it's running at 25%, which has the fan actually stalled. So let me manually pull that fan up to 50%. Before that ought to have it spinning. Actually, it's not. Oh, there it goes. Alright, we're going to have to change some settings just because that fan doesn't stay running at that level setting. I think I can take it down to about 35. Of course, I could have left it off. That would have let us see what happens with no fan, but I don't want to mess my fan up either. There goes the infill. Look at that. That's looking. So I have the camera mounted on the printer, so this is giving you a good idea of just how much the printer itself vibrates, because you're getting every bit of vibration traveling right up to the camera. All right. Well, with that, I'm going to assume that this will continue, and we will attempt to keep recording everything, but I'm going to go look for a power supply that I can plug this thing in to keep it running. Well, not sure why my video stopped partway through. So we are back. And the good news is we didn't come back to spaghetti, so. Except the camera keeps trying to fall down again. Seems like it's taking a little longer than predicted, though. That's interesting. But so far, our Benchy doesn't look too horrible. We're actually getting close to the most interesting part of this, which will be trying to do the horizontal bridge on the front window. So basically that part there. So we'll see. It's interesting, the pitch is getting higher the higher we go. Showing 10 more minutes, so I'm going to step out again. So it's an awfully small print for such a big printer, but I have to say that I'm moderately pleased with the fact that this came off looking this good. Apparently I have my starting height tuned that well, at least if I put tape down. And boom, there we're done. Well, that's disappointing that does not home. I'm assuming that is a setting for the slicer to address. So let's home X and Y, just to get the print head out of the way. And let's see if we can pop this off and peel our raft off, which is a little tight. Alright, so the raft settings need a bigger air gap, it looks like. It's not peeling off clearly. If I let it cool off, it probably would have done better. Alright, so let's look. So, again, the raft's a problem. We had some layer height issues. Let me go to autofocus here. Come on, autofocus. There we go. All right. So you can see the layer height issues there. Now that's in the same region where we had something odd happening on the Robo 3D. Generally, it's pretty smooth. It's actually a little smoother than what we got on the Robo 3D. I think we're over extruding slightly on the Robo, and so that's why you're seeing a little bit of need to actually zoom out here. There you go. So it's a little rougher around here on the Robo actually than it is here. And I think that's because the settings on the extruder is probably extruding a little heavier than it needs to. So from that standpoint, I'm pretty happy. Again, this is just default settings on Cura. From the top, not quite as shiny inside the bed. I'm not sure what that necessarily means. Less filament threads. Probably means retraction was a little better. So yeah, so other than this stair-stepping on the overhang that I don't think is supposed to be there, but might be worth looking closer at the model to see whether that's real or not. In all, looks pretty good. So, with that, I am going to call it quits on our initial evaluation. We've actually made a print, and I have a couple of boats to show for it that I'm dropping on the floor. And so when I have time to get back to this, then I will clean up all my wiring, finish closing it up. Hopefully by then, if they're providing one, Folger Tech will have sent me the fan for the control box. If not, I think I'll probably still go ahead and buy a 24-volt fan and fix that myself. Because, obviously they thought it was a good idea, and the fact that they put the mount there, it certainly would make sense to use it. So, well, thanks for going with me through this process. I'm sure I'll create another video or two once I get a little further along. The one thing, since again this is a learning curve for me for Repetier, I've got to figure out where the settings are to actually do the full bed leveling, and I also need to look at adding the display and everything on the front of the printer. That will come back as a looking through the firmware and everything for that. What I've seen is that that's designed to be a it's designed to be a Wi-Fi Repetier server. So you put the server on the Wi-Fi module and use that then to drive the printer, and you still can have the PC-based software controlling it through the server. So that should be interesting to give that a shot. So with that, thank you very much. And here we have our completed printer, more or less. So back up and try to get us a full shot. And unfortunately, my camera is jumping all over the place again. All right, so thanks again.